Hi guys, welcome back. Today we're going to be looking at finding equations of straight lines. This is year 10 of the Victorian curriculum, so hopefully you get something out of it. So, how do we find the equations of straight lines? Well, we need to find two values, and those two values are the gradient and the y-intercept. Sometimes this is known as our m and our c. So if we look at y equals mx plus c, what we're really looking for here is our m values and our c values. And then what we generally do is once we've found them both, we put them into our formula. So how do we find the gradient? As we know from previous lessons, the gradient is the change in y values against the change in x values. And the rule we use to find that is m equals y2 minus y1, x2 minus x1. And what that means is, just so you can interpret it properly, is if we have 2 points, x1, y1, that's not very good, is it? x2, y2. What the 2 and 1 actually represent are which point it is on the line. So the ones represent the x and y coordinate of point 1. We'll call this point 1. And this will be the x and y coordinates of point 2. So all we need to do is pick 2 points on the line, which it doesn't have to be a specific 2 points, it can be any 2 points. Generally speaking, most questions will give you the 2 points. Substitute them into the rule and then simplify the fraction, and that's all there is to it. So let's have a look at some gradient examples. So let's start the gradient of the following lines. We have 6 examples here, and we can use our rise and run as well, but because we haven't got a grid to go with, it's a bit harder to count them. So in this case, it's probably easier to use your rule. So I've got 2 points here. I'm going to call this point 2. I'm going to call this point 1. So that means my x1 and y1 are going to be -4 and -4, and my x2 values are going to be 0, -4. So remember, our y-intercept has an x value of 0 and a y value of 4. So we're going to put it into our formula. y2, which is 4, minus y1, which is -4. Notice that I've put brackets around the second number because it's negative. I don't want to get confused and accidentally leave the minus, which is part of the formula, and not have that negative in front of the -4. X2 is 0 minus x1, which is also -4. And then it's just a matter of evaluating. So 4 minus -4 is 8. 0 minus -4 is 4. And then we simplify our fraction to get 2. And we're done. So our gradient in this case will be 2. Second one, we have m equals y2 minus y1. I always try to use a point that is the left one as the first point and the right one as the second point. In this case, we've got our origin here, so the point 0, 0 is going to be our first point. So we're going to call this point 1, and we're going to call this point 2. So we're going to go y2, which is 3, minus 0, which is y1. 1 minus 0 for the second part. So we end up with 3 over 1, which gives us 3. So as long as we put our numbers in the right spot, we're not going to have too much issues here. Now, this one's a special one because it is a horizontal line, not a diagonal. We don't need to use We don't need to use the y2 minus y1, but it still gives us the answer that we want. So I am going to pick just a point on the line. Let's pick this one. We'll call it 2, 2. Call that point 2. We'll call this point 2, and we'll call the y-intercept point 1. So we've got y2, 2 minus y1, which is 0, 2, over x2, which is 2, minus x1, which is 0. What we end up with is 0 over 2, which gives us a gradient of 0. So obviously it's pretty obvious there. If you think about gradient as a measurement of how steep something, if it's flat, then it's going to have a 0 gradient. So for these ones, I'm not going to put in what 0.1, 0.2. I'm just going to go with it. My first point is at 0, 0, which is the origin. My second point is 1, negative 4. I'm going to go from there. So we've got negative 4 minus 0 over 1 minus 0. Now, if you want to be safe, you can put brackets around the second one. You don't need to if they're positive. You do need to if they're negative. So we end up with negative 4 over 1, which gives me negative 4. So my gradient in this case is negative 4. In other words, it goes down 4 for every one across. E, we have 0, 2, and 2, negative 4. So we have our y2, which is negative 4, minus our y1, which is 2, over our x2, which is 2, minus our x1 is 0. We once again evaluate, and we get negative 3. Don't work across the page, please. Work down the page so you can see your steps one at a time. In this case, I'm a little bit constricted with space, so different situation. So last one here is vertical. Now, I'm going to use this point, which is negative 1 and 1. So we're going to have, well, I guess it doesn't really matter which one I do. We'll go with the top one as the first one, the bottom one as the second one. So we'll have m equals, so it's 0 minus, so y2, which is 0, minus y1, which is 1, over x2, which is negative 1, minus x1, which is negative 1. And what we get here is negative 1 plus 1, which is 0. We can't divide by 0, so therefore it is undefined. Now, we don't need to do that for those kind of ones. We can actually just go look at it, and we can see that there is that is undefined, and same with horizontal, we can say that it's 0. We don't have to do that calculation to get to that point. Our second example here is when we don't have a graph, which is actually quite simple. So what we tend to do to start off with is we label our points. I like to actually go x1, y1 underneath them, and x2, y2 underneath them, just so I can see visually what x1's equal to, what y1's equal to, x2 and y2 equal. You can actually do that with the other ones, but I thought it's probably easier to do it with this and show that a bit better. So my gradient, my beautiful M there, apologies, I'm actually using a different sketch pad tonight. Negative 2 minus 8, which is y2 minus y1, over 5 minus 3, and we end up with negative 10 over 8, which is negative 5 over 4. A common question I get with these kind of problems is, does the first one have to be 0.1 and does the second one have to be 0.2? No, it doesn't. I can actually switch them and I'll still get the same answer. If I was to switch them, I'd be switching the 8 and negative 2 on the top. So I'd have 8 minus negative 2. and then I would, on the bottom, I'd switch -3 and 5, so it'd be -3, -5, and we'd end up getting our same result, which is -5 and 4. It switches the negative, but it's still a negative divided by a positive, which still gives us our same answer. So how do we find the y-intercept? Well, generally there are two ways we can find it. If we've been given the y-intercept coordinates, so that can either be on the graph so we can visually see it where it passes through the y-axis, or if I've been given a coordinate that's in the form, say, 0, y, in that case we know that that is actually where the y-intercept's going to be. The second part is when we have the gradient. So if we have the gradient, when we have this situation, we have to substitute to find C. I guess we'll call it C. With the first one, we're being given it, so we're just saying C equals this. So we'll go into an example in a second. So find the y-intercept example. If you want, you're more than welcome to try these before I go through them, so you can pause the video, practice them yourself and see if you can do them. So this one, what we've been given here is we've been given a point. So like I said before, you substitute a given point into it and then you find it. And each one is essentially a set of coordinates that we substitute in. So we're sort of making an implication here that this is a point that's on the line. It has a gradient of -2, and we're working back to find C. We've got 2 equals -2 times 3 plus C. So we're going to solve for C here. We're going to add 6 to both sides to cancel that out, and we get C equals 8. Important thing to note that the C value is not the same as the Y value, okay? So don't get confused between those two. The Y coordinate is any one along the line. The C value is a particular Y value on the line, which is our y-intercept. So make sure you know the difference between those two things. So for B, same thing. So it's a bit of rinse and repeat here. So we've got -4 equals -2 times -1 plus C. Work back. So we've got +2 plus C minus 2. Cancel that out. And we've got C equals -6. So our y-intercept in this case would be -6. Last one. We have 5 over 2 and 7, so we've got 7 equals -2 bracket 5 over 2 plus C. 7 equals, so the 2's are going to cancel out to leave -5 plus C. We're then going to add 5 to both sides, or at least attempt to add 5 to both sides, and we get C equals 12. Now, I could state my equations in each one, but if I actually look at the problem here, it's only asking me to find the value of C, so I'm only answering what the question's asked me. Don't go into that automatic frame of mind where it's just like, oh, now that I've found M and C, I'll put it into the equation and get my answer. No, the question has only told me to find C, so I do what it's telling me to do. So let's put it all together. Generally speaking, you'll have 3 scenarios when you find an equation of a straight line. We have 2 points including an intercept, so we might have something like 0, 3, and 2, 7. So in this case, we have a y-intercept. In this case, we will state our C value and use m equals y2 minus y1 over x2 minus x1 to find our m value, and then sub our values into y equals mx plus c. So in this case, we get our c value, we use our gradient to find our m value, we can get to our answer. If we get 2 points not including the y-intercept, so we might have 2, 7 and 3, 10, for example. In this case, we have to find m first, and then sub m and a point to find c. So in this case, if we look at y equals mx plus c, we put m into it, and then we put a coordinate xy into it. Either one would be fine because they're both on the line. So they'll give the same c result. If you don't, that it means you've probably done an arithmetic error. So if I've got 1 point in gradient, what I can do is I can still do that. I can actually go straight to here. I can do that. There's also a different rule that we can use, and that rule is y minus y1 equals mx minus x1. The beauty of this is it actually almost puts it in mx plus c form when you've put those, when you put your point in and when you put your m in. And I'll show you here. So if I have m equals 2 and the other point was 2, 7, what I'd end up with is y minus 7 equals 2 bracket x minus 2. So y minus 7 equals 2x minus 4. Now I just need to add my 7, and then I get my rule. So this can be useful if you're working with the 1.1 gradient. A little bit harder when you've got 2 because you still have to find the gradient first. You still could use that as your second method. It's really up to you. So let's find the equations for these particular ones. So we've got our great y-intercept here. We've been given 2 points, our y-intercept and another point. So that tells me I'm going to state my y-intercept first. So c is going to equal 1. I'm then going to substitute now if I wanted to, I could, there are actually a couple of ways that we can go about this. I did mention that if we were given it, we state it, and we can use m equals y2 minus y1, so we'll do that. So let's go 13 minus y1, which is 1 over 4 minus 0 gives us 12 over 4, which is 3. So therefore, my equation is y equals m, which is 3x plus 1. Easy enough. Other way I could do it is if I think about y equals mx plus c, I can put c in and then substitute the other point in to find it. So I could go 13 equals m4 plus 1, and now I can work back in that sense. So I can take 1 to both sides. 12 equals 4m, m must be 3, and then I can state my answer because I end up getting the same value anyway. So either, it still works. They're still both valid. The second example here, we've been given 2 points and we haven't been given the y-intercept, so we have to find the gradient first. So let's find our gradient. Right one is our point 2. This is our point 1. So we're going 7 minus 11 over 6 minus 3, which is equal to negative 4 over 3. So I've done that first. Now, if I want, I can use that other formula, but I'm going to do the substitution method because I showed that before. So we're going to write this into our equation. So 4/3 x plus c. I'm going to pick a point. In this case, I am going to pick 0.1. So I'm going to put 0.1 in there, and that's because the x value is 3 and the denominator of that gradient is 3, so they're just going to cancel out really nicely. So we're going 11 equals negative 4 thirds times 3 plus c. These are going to cancel out to leave negative 4 plus c. Add 4 to both sides, and we get c equals 15. Make sure you do state your equation at the end there. So therefore y equals negative 4 thirds x plus 15. Now, always good to, especially if you already have a graph, to just double check with that it's actually where it should be. So I see I have a y-intercept of 15. If I look at my graph here and I go up, I know it's going to be at least greater than 11, and so 15 is pretty reasonable for a y-intercept in this situation. Thanks for watching. If you liked it, give it a thumbs up. If you didn't like it, thumbs down. Always let me know if there's anything I can do to improve it. I sincerely apologise for the writing today. I did actually get a new, well, not a new one, but my old tablet, and it's very hard to write with. So hopefully I'll do a revision in the future when I get a new one. If you have any requests or any questions about anything, please let me know in the comments, or feel free to email me. My email will be in the description. Thanks for watching. See ya.